Hi dear students, welcome to Geeta's classes. In this class, we are going to find out the Laplace transform of some more functions using the elementary functions. We are going to do some problems on that. So first, in the previous classes, we have seen the proofs of all these functions. We have found out the Laplace transform of the elementary functions like this. So if you want to be thorough with these things, you can please go through the previous classes. Now we are going to do some problems using the elementary functions. So L of k is equal to k, we know. So L of 3 if you want, then 3 by s, right? So L of e per, using the same functions, you have to remember the Laplace transform of these elementary functions. So just we are going to substitute the values of a. So L of e per 5t is equal to 1 by s minus 5. Using the formula only, L of e per minus 5t. E per minus 6t is equal to 1 by s plus 6. L of sine 9t is equal to what? A by. So here a value is 9. So 9 by s squared plus a squared. So s squared plus 9 squared, that is 9 by s squared plus 81. So L of cos 60 is equal to s by s squared plus a squared. So s squared plus a is 6 here, so 6 squared. So s by s squared plus 36. L of sin h 3t. L of sin h 3t is equal to 3 divided by s squared minus 3 squared, that is 3 divided by s squared minus 9. So next is L of cos h 2t is equal to s divided by s squared minus, for hyperbolic function minus, so 2 squared. That is s divided by s squared minus 4. L of t power 5, n factorial. This is an integer, so n factorial divided by s per n plus 1. So 5 plus 1. That is, here n is what? 5. So 5 factorial divided by s per n plus 1. Okay, so 5 factorial divided by s per 6. Sometimes the values will be given like this, and if the power is not 5, not an integer, then we will do a separate problem. We have to use gamma function. Okay. And sometimes the Laplace transform will be, you will be asked to find out the Laplace transform of functions like this. Function will be defined like this. Then you have to apply the formula. So integral L of f of t is what? By definition, it is integral 0 to infinity e power minus st f of t dt, right? So this is equal to, now it is defined from 0 to 1, it is defined as 1. 1 to 2, it is defined as, in this interval it is defined as 1. In this interval it is defined as t. And the next interval, that is up to infinity, it is 0. It is 0. Okay. So we will split the interval 0 to infinity into 3. So integral 0 to 1 e power minus st into 1 into dt plus integral 1 to 2 e power minus st into f of t is t there into dt plus integral 2 to infinity e power minus st into 0 dt. From 2 to infinity it is defined as 0. So this is equal to integral 0 to 1 e power minus st dt plus integral 1 to 2 e power minus st t into e power minus st. For my convenience, I will write like this, e power minus st into dt plus 0. Okay. So let us integrate that, e power minus st by minus s from 0 to 1. This is equal plus e power t into, so t into, you write like uv formula. So e power minus st by minus s, you keep on differentiating the first function. Minus of t is 1, e power minus st by, already we have one minus s, we will get one more minus s here. So minus s the whole square, or we can write it as s squared from 1 to So if you apply the limits, this is equal to, when you apply, here we have integrated with respect to t. So wherever you find t, you apply the limits. Upper limit first, then minus of lower limit. So e power minus s into 1 divided by minus s minus e power 0 divided by minus s. Okay. Plus here, apply t is equal to 2 here first. So 2 into e power minus 2s divided by minus s minus of e power minus 2s divided by s squared. This is for upper limit. Minus lower limit is t is equal to 1. So 1 into e power minus s into 1 divided by minus s minus of e power minus s by s squared. So which is equal to e power minus of e power minus s by s. This minus minus will become plus. So e power 0 is 1. So it is 1 by s plus or minus 2 into e power minus 2s by s. Then minus e power minus 2s by s squared. Then minus minus plus, so it will become plus e power minus s by s. Again one more minus and minus, it will become plus, so plus e power minus s by s squared. So this is equal to, here e power minus s by plus s and minus, these two terms are opposite, so they will get cancelled. So 1 by s minus 2 into e power minus 2s by s, then plus e power minus s by s squared, this term I am writing, and minus 2 e power minus, e power minus 2s divided by s squared. This is the answer. So sometimes the direct formula can be asked, or sometimes they will ask the function like this. In this case we have to apply the formula. We will do some more problems in the next class. Also next is using first shifting theorem. We will see the proof for first shifting theorem and problems using the first shifting theorem also. And please like and share it with your friends. It will be so that it will be useful for others also. Thank you so much for listening.